So today we'll look into a problem from kinematics asked in Russian Olympiad way back. I don't know which year. Uh, the reason I'm taking this up is because this is a very basic conceptual problem, and all students who are opting for NEET or even JEE Advanced, they should actually understand it. So let's look into the problem, and you have the problem shown on screen, but I have divided it into three parts. Okay. First part is about the motion in an inclined plane of length L. Second part is for a portion of a curve which has one single center of curvature and it has a radius of curvature as r. This r is much bigger in size compared to the whole path. So r is much bigger than 6L. And last part is motion in a horizontal plane where the distance is 3L. Now, what is provided to us? It has been provided that the initial starting point of the ant, the velocity is 0. Okay. And we have to calculate the total time that the ant takes to go from point A, B, C, and to D. Okay. So first part and third part, that means calculation of T1 and T3, I am not going to solve it. You guys should solve it and comment the answer. I'll focus on the second part, okay, where the ant is slipping in a curved path. Okay, so before actually we solve this problem, what we need velocity at point B and velocity at point C. Then only we can do something about it. To get to the velocities, what we need is we need to calculate this theta. So what is this theta? This theta is equal to L by R. Can we say that? Because this is R, so the length of this arc is R theta. R theta equal to 2L, so theta is equal to 2L. Okay. Now you can also see I have mentioned height H1 and H2 because I want to do energy conservation. So for calculation of H1, what we need is this L length is provided, this theta we have already estimated. So what is H1? H1 is equal to L of sine theta. Now theta is very small. Why? Because R is much bigger than 6L. So it is much bigger than L. So I can simply write this as L theta because sine theta becomes theta when theta is very small. Okay. Now let's talk about H2 height. How to calculate H2? We have to first know what is this. This one is R times cos theta, right? So this is R cos theta. So how do we get H2? H2 is nothing but R minus R cos theta. So I can simply say R minus R cos theta. And what is 1 minus cos theta? 1 minus cos theta is 2 times sine of theta by 2 square. Okay. Now theta is much smaller. So theta by 2 is further smaller than that. So I can simply write that R into times theta by whole square. And what is this? This comes as R theta square by 2. So we got H1, we got H2. Now we can jump on to energy conservation. And how to do that? We already know the velocity at point A is 0. So let's do the energy conservation from point A to point B. Let's let the velocity at point B is Vb. So half m Vb square is equal to m times g. And what is this height h1? This height h1 is L theta. So I can simply say L theta. So if I calculate Vb square, it comes as 2gl into theta. And what is that theta? That theta is 2L by R. So Vb, after all the calculations, we can simply say it is 2L root of G by R. Very good. So we got the velocity at point B. Now let's calculate the velocity at point C. Let's do the same thing from point A to point C. Now the height will be h1 plus h2. So it will be half mvc square is equal to mg L theta plus r theta square by 2, r theta square by 2. When you calculate everything, I'll directly hopping on to the value which is equal to 2L root of 2G by r. Okay. So we can simply see that VC is root 2 times VB. Just remember that. Okay. Now, once we understand and figure out the velocities, now think of the motion, how to calculate time. Okay. So to calculate this time, you have to understand how this motion is behaving. Don't you think it looks like a simple harmonic motion, or a simple pendulum is actually moving from B to C? Because everything is happening under gravity, right? There is no other force. So you can estimate it as there is a bob. Let's say this is the mean position. So this position becomes C. And if we go to the extreme position, this is the extreme position. Problem is that extreme position does not have a velocity. So B is not that extreme position. It is somewhere in between. So let's say what is that position? Let's say this is that position and this is the whole curve. But this is B and this is C. And this angle is theta. Okay, got it. So now we got velocities at two different points. So how do we even calculate the time? It is a tricky thing because it has an angular velocity which is changing. It has an angular acceleration that is also changing. So too much of calculation, right? No, you have to go to the basics. That means write the expression for the position of the particle in a simple harmonic motion under gravity. What is that? That is simply x a times sine of omega t. Why I did not add 5? Because I want to do the calculation from C. And at x equal to 0, my time is 0. Okay. So, if a body is coming from B to C in a simple harmonic motion and taking time t, then when it's going back from C to B, it will take time t. That is the simple concept. So, what we'll do is we'll think of it that the particle is going from C to B. For determining it, we have the position. So, if we differentiate it with respect to time or find the derivative with respect to time, it is equal to cos of omega t. Now, my velocity at C is the maximum value. So, I can simply say Vc. So, for maximum value, t has to be 0. And this expression is for 0 value is 1. So, this becomes a omega. For Vb, I know the time taken is t, which is t2 in this case. So, I will simply say a omega cos of omega t2. Now, I just said that remember that Vc by Vb was root 2 or Vb by Vc is equal to 1 by root. So, if we do Vb by Vc, this comes around cos of omega t2 and that is equal to 1 by root 2. What is the cos inverse of 1 by root 2? Cos inverse of 1 by root 2 is pi by 4, right? And when this is pi by 4, then T2 is equal to pi by 4 omega. Now, where do I get omega from? For a simple harmonic motion under gravity, this omega value is always constant and is equal to G by R. In R in this case, most of the time you will see this formula as G by L, which is the length of the string. So, if you replace that in T2 expression, it comes as pi by 4 times root of R by G. So we got the value of T2. Okay, now you can see that the value is only dependent on R and G, and R is the only one data which has been provided in the question. Rest of it is in ratio. So L is not coming into the picture, theta is not coming into the picture. Okay, so you will get the similar expression for T1 and T3 and R and G for. So what is that value? Comment. Okay, so we can calculate the total time. Okay, thank you.